Okay, thank you. So now I'll talk about quality of service. So I have a different slide for that. So please confirm if my slide is visible to all of you.
Yes, sir, it is visible.
Yes, sir. Visible, sir.
Yes, sir. Visible.
Thank you so much. So the topic of this session is quality of service in 5G, how we manage quality of service in 5G. Some bit of it we covered as part of 5G core, I think yesterday. I'll repeat few of the slides to make it, in continuity of the entire thing. So in this session, we'll talk about PDU session and QS flow, which we had already talked earlier. So that will be a recap. And then we'll talk about 5G quality of service architecture. So what kind of architecture is defined in 5G to handle quality of service? And then there is a concept of default quality of service flow, guaranteed bit rate type of a quality of service flow. Then there are quality of service rule, quality of service profile, SDF template. What are these terminologies we'll talk about? And then how quality of service flow is mapped. So mapping part of it. Then how quality of service is there in a network slice. What are different types of quality of service and parameters? There is a new concept of alternate QS profile. Then we have a 5QI, 5G quality of service uh, indicators or ID. What is the characteristics of that? And then what are the standard values of 5QI? So these are the topic I'll try to cover in next 40-45 minutes. Maybe I can exceed 10 minutes or so because we were delayed in the morning. And then we'll compare with 4G. Okay, so in case you want to go deep into these, there are many standards. For example, if you look at uh, the generic standard, that is 38.300, section 12, just one paragraph talks about uh, QS architecture in 5G. That's just one paragraph there. And if you look at 23.501, section 5.7, so there also you have slightly more detail on quality of service. And then how the procedures part, like how those procedures happen inside, is given in 23.502. Uh, the QS flow binding parameter mapping is coming from this particular standard. Uh, there is something called QS information element. It is coming from this standard, and the mapping comes from this. So basically, there is another protocol which has come into play in 5G called SDAP, Service Data Adoption Protocol. So about uh, SDAP protocol, you can read in this. So you can anytime download these documents and try to go through in case you want to go more and more detail into it. Okay, so yesterday we had talked about that in 5G SBA architecture, I have user plane and I have control plane separately. And then in the user plane part, a PDU session is required to handle the data traffic, and PDU session is nothing but series of connection from UV to G node B to UPF and towards the data network. So yesterday we know that whenever a new device is switched on, or a device want to connect to the network for data traffic, the first thing which happens is the creation of PDU session. Of course, after authentication and authorization, once uplink synchronization, downlink synchronization, authentication, authorization is over, a PDU session is created for the user, and PDU session is unique to the user equipment. So one the PDU session will not be shared among UE, but a unique UV will utilize the PDU session created for it. The second thing which we had discussed is that within that PDU session, uh, initially there'll be a default QS flow added. So every QS flow will have an ID. We call it QFI, QS flow ID, which will be added to the PDU session. So within this PDU session, in addition to the default QS flow, many other separate QS flow can be added, and every QS flow will be identified by a QFI number. So if you look at this picture, that default QS flow is added to a PDU session for the user equipment, and this will be be available for lifetime of this PDU session, and this will give you some sort of best effort service, non-guaranteed bitrate kind of a service. And over a period of time, when user want to avail more services, so more number of quality of service will be added depending upon what service it is trying to use, in addition to the default QS flow. And these additional QS flow can be modified or can be terminated as and when it is required. Like for example, if you have stopped using say a Netflix service, so the QS flow required for that will be terminated from the PDU session. But your default QS flow will continue till you have a PDU session created for you. So to summarize, after registration process, a PDU session is established for a user equipment, and that PDU session is unique for a particular UV, and there will be a default QS flow added into the PDU session, and quality of service is enforced at that level. So that means QS flow is the uh, granular level of managing quality of service in 5G. Then packet are to be classified and marked that what is the QFI ID, because this marking will enable network to identify that what kind of quality of service has to be given to that QS flow. So every QS flow will have a QFI, and that will be marked. So user equipment marks uplink traffic, and the UPF will mark in the downlink traffic. And then there can be multiple QS flow within a PDU session. As we saw, there can be multiple QS flow in addition to the default QS flow within the PDU session. Any question till this point? Should I proceed?
Yes, sir.
Right, thank you. Okay. Now let's look at, this is very important. I seek attention of all of you. Few minutes, just understand this particular QS architecture of 5G. So in this diagram, this is UV. So this part is indicated as UV. Then we have G node B, and then we have UPF. Okay. So as we say that a PDU session gets created. So the yellow pipe which you see, here is like a PDU session. So now let's look at between UV and G node B, that is the air interface. So air interface is nothing but your frequency and time resources. So there we call it within the PDU session, resources are allocated. So those are called DRB. So this blue color which you see is a DRB. DRB is data radio bearer. It's nothing but a certain number of resource block over period of time. And you have another DRB within the same PDU session. Just you can see here, the another DRB is also present. So there can be more than one DRB between UV and G node B interface within that PDU session to handle that PDU session. Now, if you look at from G node B to UPF, It is a single tunnel created for the PDU session. This is a single tunnel. On the radio, I have multiple DRB, but between Z node B and UPF, it is some sort of fiber or Ethernet type of connectivity. I have a single tunnel, and this tunnel is GTP, GPRS tunneling protocol it follows. So GTPU, and since you know that the interface between G node B and UPF was called N3, so that's why the name has come N3 GTP tunnel, and U is for user plane because this handles only the user plane data. Okay, now let's go back to UV and G node B, between UV and G node B. So now in this overall PDU session picture, we have suppose this one, green one is a default QS flow, which was created when PDU session was created. And then assume that QS flow 1 and QS flow 2 was added later on, right? So now currently this PDU session have 3 QS flow. So what we can summarize is that there can be one DRB or more than one DRB in a PDU session. And within a DRB, there can be one QS flow or there can also be more than one QS flow. But between G node B and UPF, I have a single tunnel and all the QS flows are flowing through that tunnel itself. So this is the concept of QS architecture. Okay, so any question here in this particular picture, any of you? Did you understood or understand, or it was like, you can say yes or no?
Yes, sir.
Yes, sir, we understood.
Okay.
Okay, sir.
Okay. So now, so there are various types of quality of service flow which is possible in 5G, and those are like QS flow with GBR, guaranteed bit rate, QS flow with non-GBR, non-guaranteed bit rate type, and there is something called delay critical GBR because we have to handle URLLC kind of application, which is delay critical. So we have a delay critical GBR, guaranteed bit rate, and there is something new called reflective QS. So reflective QS is like whatever quality of service is applied in a downlink direction of the packet, the UV can extract that and apply in the uplink direction of the packet. So that's why the name comes as a QS, reflective QS. So these are 4 types of quality of service flow in 5G. So to summarize whatever we discussed, there can be one or more PDU session for every UV. So this we had not discussed. Basically, a new thing which has come that one UV can have 2 PDU session, more than one PDU session. So can you guess in what scenario there will be more than one PDU session? Any guess? Any idea?
And it is handling different applications.
Accessing Netflix, YouTube, maybe.
So basically, when UV, one example can be when UV is having dual connectivity, one through the new radio, other through Wi-Fi or any non-3GPP. So you have multiple PDU session on the both the one PDU session in one side and one PDU session in other side. So UV is having more than one PDU session, but one PDU session will always be unique to UV. And then we talked that there will be at least one DRB if there is a QS flow within the system. So there has to be one DRB. For example, if a default QS flow is created, so at least one DRB will always be there as long as this PDU session exists. So what is permanent is the along with PDU session is that there is a default QS flow and there is at least one DRB that will always be there. And then additional DRB can be added subsequently once we are able to access other services having different quality of service. And then if the packets are coming from different PDU session, as I said that you can have more than one PDU session. In that case, DRBs will always be different. DRB can be different for different quality of service, but if it is coming from different PDU session, so there'll be a different DRB. And finally, it will support GBR, NGBR, delay critical GBR, and reflective QoS. Okay. So this we have already discussed that a default QoS flow, that whenever a UV turns on or try to use a network, a PDU session is created and there'll be a default QoS flow added. So this default QoS flow is based on the configured data, what has been configured for that UV. I mean, what resources are to be given, what speed are to be given, will be decided by the subscription. And this will be there for lifetime of the PDU session. And this is always a non-GBR type QoS flow. So default QoS flow is always non-GBR. So this is important to remember that the QoS flow, the default QoS flow will always be a NGBR type. Okay, now let's look at this picture. So let's assume that a UV1 or a UV for UV a PDU session is created and a default QoS flow is added, and that default QoS is this. And within the default QoS flow, there can be one or more than one service data flow. SDF is nothing but the different services like YouTube or Netflix or any ARVR. So, I mean, those services which are kind of a non-GBR or all the OTT kind of services, please understand, over the top services which are, I mean, they use just the internet best effort service. So all those SDFs are added in this. Now suppose the user equipment UV want to access a gaming service. So there will be a application function of gaming. So using the default connectivity, UV will be able to go to this application function, authenticate itself and say that I want to use the gaming service. Now this application function has connectivity with PCF and it will ask that for a particular UV1, please enable a GBR type of quality of service. So this PCF will ask SMF and then SMF will instruct UPF to create a GBR type of QoS flow. So, so what is created for this is the additional QoS flow within the same PDU session, which is GBR type, and their DRBs are added, and a particular SDF of gaming is added. Suppose that gaming SDF is this one. So within the QoS flow, this SDF of gaming is added. And now suppose parallelly, we also want to avail ARVR service. So suppose there is another application function or the server which is handling ARVR. So the UV will connect to ARVR through the default connectivity which it has parallel in the sense that it's already availing gaming. and ask that I want to avail ARVR. So in that case, this AF will also talk to PCF and request for a required quality of service, and then PCF to SMF and then to UPF. So now UPF knows that there is already a GBR type of QS flow created, and the quality of service requirement is same. Suppose assume that same. So within the same GBR QS flow, another SDF can be added by the system. And in one of the SDF, it is gaming, and in other SDF, it is ARVR. So this is how a GBR QS flow can be added onto the existing PDU session. Okay, so any question till now?
No, sir.
Okay. So what are the different ingredients?
Sir?
Yeah, please.
Parallelly, how many sessions can be established for application use case scenarios?
So how many you are saying sessions, or how many SDF or services it can
Tunnels.
avail?
How many tunnels can be established?
So in fact, standard has not given a limit as such that how many services one user can avail and how many QS flow can be added in PDU sessions. So those limitations are not prescribed in the 3GPP standard. It is up to the operators or OEMs to configure that parameter. Generally, any user device, suppose a user device will avail how many services in parallel or simultaneously, maybe 5, 6, 7, 8, not more than that. So, so I think those limitations or configuration can be done by the operator in their network, but standard do not really put a limit to it.
Thank you, sir.
Okay.
Sir,
So what are
regarding-
different? Yeah.
Regarding sessions, is there any limit, maximum limit on PDU
Or
session?
limit for?
PDU session, sir.
No, that is also not a limit, but there is a limit related to network slice, that how many network slice one user equipment can access parallelly. That limit is defined as 8. And if you read network slice specifications, so there is a limit defined about 25 PDU session. Okay. So at the slice level, definition is of 25 PDU sessions. So I'll cover that when I go through the network slicing lecture, right?
Okay, sir. Thank you.
So there'll be more granular information related to it.
Okay.
Okay. So what are different ingredient for quality of service flow? So one is called QS profile. One is called quality of service profile, right? And this quality of service profile is provided to RAN, radio access network, that is Z node B. And who provides? SMF provides. SMF, of course, it do not have direct connectivity. So through AMF on N2 interface, the G node B will receive QS profile. So whenever a user equipment is requesting to create a PDU session, as part of the PDU session creation, RAN will receive the profile. And what this will contain, I'll talk about later. But this will come to the G node B through SMF. So that is the first ingredient of a quality of service flow. The second ingredient is the QS rule. Quality of service rule. So quality of service rule will be provided again by SMF to user equipment. Of course through MF, because SMF will not have a direct connectivity on N1 interface. Okay. And I talked about reflective QoS. In case of a reflective QoS, it has to derive from the downlink packet. Otherwise, SMF will provide this. And the third ingredient is, we call it PDR, packet data rule, filtering rules we call it. This will again be provided by SMF to UPF. So in user plane part, you have UV. So UV receives rules. You have RAN. RAN receives profile, and you have UPF. UPF receives PDR. This is also called SDF template, Service Data Flow Template. Okay, so these are the three main ingredients to handle quality of service flow in 5G. And SMF, how SMF creates rules, profiles, and SDF template based on it receives information from policy control function, because policy related decisions are taken by PCF. So PCF provides certain guidance to SMF, and based on that guidance, SMF creates rule, profile, and the PDR. Now we will go through these ingredients in slightly detail. Starting with QS rule for UV. The first QS rule, this one I'm trying to cover first. Okay, so what are different rule for UV? So this can be a rule for UV can be so the rule are normally provided during the creation of video session, or it can also be configured in advance. So UV can be configured in advance, and then UV can drive that rule through the download packet when it is using the reflective QS. So what are these? So first is the packet filter. So basically in uplink direction, so if you have a mobile phone have so many applications, app, YouTube, LinkedIn, WhatsApp, gaming, so many things. So those are nothing but service data flows, SDF coming, service data flows coming in the uplink direction towards the UV and then to the radio. So now UV has to filter that, which of the application will have what kind of quality of service. That information can be done by filtering it. So filtering may be done by certain parameters so that you identify that whether the IP packet is a YouTube packet or a gaming or AR/VR. And then QFI, quality of service flow ID. So that is also provided to the UV, that if you filter and know that it is X, then you have to apply QFI number what. And then there is something called session umber. Umber is aggregated maximum bit rate at the session level. So how much maximum bit rate would be possible at the session level for UV? And then you have what kind of PDU session it is. Is it Ethernet type PDU session or IP type PDU session? So there can be more than one type of PDU session. And then we are provided, the UV is provided with something called SNSSI. So basically it is for selection of network slice, which network slice it has to go, the traffic has to go. And then we have precedence number. So precedence is nothing but, suppose you have multiple filtering rule. So filtering rule will not be a single rule. There will be a 1, 2, 3, 4, 5, 6, 7 kind of a rule. So which rule will be applied first, and then the second rule and the third rule. So the precedence data will also be provided to the UV. So this is how UV filters a packet and map a particular QFI, of course, along with G node B, and accordingly resources in terms of data radio bearers are allotted in the PDU session. Now the second ingredient was QS profile for G node B or RAN here. So what is that ingredient? So again, QFI will be required at every place because based on QFI only we know what quality of service. And here something called Umber. Umber here is aggregated maximum bit rate at UV level. As UV can have more than one PDU session, so at UV level also one has to restrict the aggregate maximum data rate, and this we are talking about air interface because you are talking about G node B. And then what kind of PDU session it is, and then also 5QI. 5QI is 5G quality of service indicator. We'll go into detail later. Then something called ARP, allocation and retention priority. Then reflective QoS parameter. In case of a GBR, you need maximum flow bitrate and guaranteed flow bitrate. So MFBR and GFBR if it is a guaranteed type of a bitrate. And there are many more parameters as part of the QoS profile. So this is what SMF provides to RAN. So this was ingredient number 2. And the third, as I talked, is the template or the PDR. So here also, so this is SMF to UPF. So you have a QFI, then you have a filters, we call it PDR or SDF filter, reflective QoS, precedence of those filtering rule, then UV address. What is the address of UV? What kind of PDN type? Like PDN can be internet, PDN can be any other service and more. So there are many other parameters. So overall 3 parameters with certain kind of a specific parameter inside these 3 ingredients. Okay, so the packet filters are what? Packet filters, either those QoS rule or SDF filters will have what? They will have IP addresses of the source and destination. They may have port number and many other parameters. If it is an IP packet type of a PDU session, if it is Ethernet, then there will be a MAC address of source and MAC address of destination, and there can be certain more related parameters. So these will be used by UV at one side for uplink traffic and by UPF on other side for downlink traffic to filter the traffic and apply a correct QFI, correct quality of service flow ID. Okay, so slightly more detail. Any questions so far before I proceed? Shall I proceed?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay, this is another example where everything is at one place: QoS rule, QoS profile, and SDF template provided by SMF to UV. QoS rule goes to UV. QoS profile goes to Z node B, and SDF template or PDR goes to the PCF. And we had discussed that QoS rule contains packet filter, QFI, session number, PDU session type, and so on. And QoS profile contains UV number, PDU session type, 5QI, ARP, reflective QoS, and so on. And SDF template also contains PDR, rules, reflective QoS, user ID, and so on, UV address, and so on. So basically, these are different parameters which are required to handle the quality of service in 5G. Beyond UPF towards the data network, it's a pure kind of a transport network. So there, if you recall that N6 interface, the quality of service is managed by something called diffserv. Many of you would be knowing. So basically, the QFI in the 5G network will be mapped to diffserv in the backend networks towards data network because end-to-end QoS has to be maintained. Okay, so how this QFI is mapped? So we call it two-step mapping. This picture is directly taken from the standards. So just look at this picture. So left side I have user equipment, then I have access network, that is G node B, And then I have user plane function. Let's first talk about the downlink traffic. So downlink traffic will come from some application and service layer to the UPF. So here there'll be a n number of IP packets coming from different services. So now UPF is required to filter that. So what they will do using the PDR, packet data rule, or SDF, service data flow template, uh, like IP address or MAC address, they will segregate these IP packet and bucket into different buckets requiring same quality of service. So, so they will now map a QFI value here, another QFI here, and the third type of QFI say here, and those will be going as a QS flow. So there are three QS flows shown in this picture. There may be multiple number of SDF flow in each of these. So this is the first level of mapping in the downlink direction. So this will go to access network. Now from access network, it has to go on to the radio where I have DRB. Those are AN resources. So here also now which QFI will go to which DRB. So here also there will be some filtering happening. So now from 3 QFI, system has decided that I can handle it with two kind of a DRB. So it has mapped into two. So those, and this is being done by the SDAP layer I talked about, service data adoption protocol. So this is being adopted here. So here also SDAP protocol, both side. And here on the DRB, these packets are mapped. So that's why we call it two-step mapping. The first mapping is happening in UPF. Second mapping is happening at AN level for downlink traffic. Similar would be the case for uplink traffic. In case of a uplink, the IP packets are coming from the applications in the UE, and then UV is using the QS rule. It is trying to filter and create a bucket, and in every bucket they apply QFI, particular QFI, and then along with G node B, certain radio resources are allocated. Those are DRBs, and once it reaches AN, it will again map to different QFIs here in the tunnel, and then it will go. So basically, it's a two-step flow in uplink and also in downlink. Any question here in two-step mapping? Shall I proceed?
Yes, sir.
Thank you. Okay, so a slightly different diagram taken from some other sources, which gives more detail how this mapping happens. So, so as I said, the different PDU types. Suppose there is an internet PDU, then there is a Netflix PDU, and there is a IMS for voice PDU. So in the internet PDU, there can be a best effort or WhatsApp or Skype video or YouTube. There can be many. And there'll be another type of PDU.
Sir, excuse
Yeah.
me, sir. I have a doubt, sir, because the direction, the flow between the G node B and user equipment,
Yeah.
the previous slide, it is different from this, sir.
No, so here it is, there's no difference. From UV, it is going to AN and then to the UPF in the uplink direction. In downlink direction, from UPF to AN to UV.
The
So
second one is, this is for uplink, this is for downlink. sir.
this is downlink. This is downlink.
Okay, okay, sir.
So both way, I mean, so it's similar. Once you understand downlink, you can understand uplink also. So this is downlink traffic. So whenever traffic is coming to UPF, it has to come from DN, data network. So it will be a downlink traffic. So there are three PDUs shown, and in each PDU there are some services or SDF. So here are two, voice and video. Now the UPF will apply that particular service data flow template or rule, packet data rules. And as I said, they will try to bucket into QFI. So what they have done, best effort services in QF1, QFI1, WhatsApp and Skype, they have clubbed to QFI2. These are just example. YouTube to QFI3, Netflix to QFI4, voice services to QFI5, and video as QFI6. So now I have 6 QS flow in this tunnel. So here there will be a N3 GTP tunnel between GNodeB and UPF. So I have in that tunnel 6 QF5. Now going to the radio part from GNodeB to UV, as I said, there'll be DRB, data radio bearer. So there'll be one or more than. So here instead of 6, they have created only 5 DRB because some of the DRB will handle more than one QFI. So in DRB 1, the QFI 1 has been mapped. In DRB 2, QFI 2 and 3 has been mapped. 4 is going like this. 3 is going 3 is mapped to QS flow 4, DRB 4 to QFI 5, DRB 5 to QFI 6. And then again, this will be filtered out so that it goes into the UV applications, right? So this is what the mapping happens of the QS flow, and those are handled. Okay,
Sir, may I ask one question?
Yeah, why not? Yes.
Sir, whatever this flow, is it following similar to our OSI model, or is there any deviation? It will follow all the layers similar to our computer networks OSI model, or
Yeah. Same. So all the layers are applicable. So name can be slightly different because if you look at radio, so suppose radio.
yes,
On
sir.
this radio side, so in the radio, you will understand that L1, L2 and L3 layers are handled. Physical layer, MAC layer and RLC layer. So these are 3 layers of your OSI which is handled. Rest, you know that will be handled at the transport and also at the application level, right?
Okay.
Yeah.
The
Okay,
one-
sir, and one more. Instead of this is user equipment is a mobile. If it is like a TV, Android TV kind of thing, is it process is same or is there any deviation?
So basically for the network, if TV is having a modem, 5G modem, then it will take that as a UV. Okay. If and if your TV is like using like UV connectivity or any other device connectivity, so the UV in that case is the other one, the 5G modem. But in spite of that, we will be able to know, the UV will be able to filter that what kind of IP traffic is coming, and accordingly it can quality of service can be managed.
Okay, sir. That means Android, suppose there is an Android TV installed YouTube app. When we
So
start
let's take an example of Netflix.
yes,
Today,
sir.
all these applications, whether WhatsApp, Skype, YouTube, and Netflix, they are all best effort service, right? Best
Yes.
effort service, and that's why we call it OTT, over the top services. So whether you have fiber, whether you have a mobile connectivity, based on how much bandwidth it is getting, you get quality of service of these services, right?
Yes.
But going forward, what will happen is like like now what Netflix or Amazon will do, that their Netflix server will directly connect to 5G network through NEF. So operator and the this Amazon will have an agreement, and in the same data center they will deploy their Netflix server, and they will agree to provide a particular say GBR type of guaranteed bitrate type of thing for Netflix services. Suppose they will decide to provide QFI 6, which will have certain parameters, right? So what will happen? Suppose as a UV, you are trying to access Netflix. So that means you have already subscribed Netflix. So now not only Netflix knows that you are a subscriber, 5G network also knows that you are a Netflix subscriber, and then it will provide you, so that application will be there either in your TV or in your user equipment. But when you access it, you are able to provide your credential for Netflix also. So both system knows that you are a Netflix user, and then it will provide the QFI 6 onto the network, so better speed. And other users who have not subscribed, they will just use their normal default PDU session, and the Netflix outside the network best effort service that they'll be able to access. So there'll be a differentiated service for those who have subscribed Netflix, which is inside the 5G network, and those who are using just a OTT kind of environment. So this kind of scenario will come in going forward environment.
Okay, sir.
Did I?
Thank you, sir. Yes, yes, got it, sir.
Okay, so this is the same picture but in a different way. So why I put it, because this gives much more newer ideas. I'll skip this. You can just go through. This
Sir,
picture is, yeah.
one doubt to the previous question,
Okay.
to the previous slide. Sir,
Okay.
did DRBs or QFI have any time limit?
Okay, so so as I said, let me talk about first QFI. So QFI represent one QS flow into the PDU session. So this QS flow will be maintained as long as, suppose this QS flow belong to Netflix. So as long as you are hooked to Netflix, this QS flow is active for you. And suppose you disconnect, you exit from the Netflix, the network will terminate this QS flow from the PDU session at that particular moment. So that is the life of a QS flow, depending upon whether you are using the service or you are trying to exit or log out the service, this QS flow will be there. And once a QS flow is not there, a particular DRB, so end to end, that QS flow will be terminated. So if that DRB was handling this QS flow alone, that DRB will also be taken back. That will become free for other users to use. And please note that these DRBs are not like once allotted is permanent. These resources in these DRBs are added and removed as per the requirement, right? So suppose these DRBs requirement are less. So on the next TTI time, the resources will be removed. Some of the resources can be removed.
Okay,
And
thank you. I got it. Thank you.
Okay, so just a summary of two-step mapping. So there is a one-to-many relationship between DRB and GTPU. So here there are multiple DRB but single GTPU tunnel. Then each QS flow is mapped to a single GTP tunnel. That means a QS flow is going to this tunnel. So it is not possible that this QS flow is also going to some other tunnel. No. So same tunnel, one QS flow, one tunnel. Although this tunnel will have more than one QS flow. Then G node B may map individual QS flow to one or more DRB. Okay. So there can be more than one DRB also possible. One PDU session, multiple QS flow, several DRB, single GTPU tunnel. In one sentence, we can say one DRB may transport one or more QS flow. This example that this DRB is having two QS flow. And then the downlink PDU session information frame includes reflective QS indicator if that is there in the if that is to be applied. In the downlink PDU session, the RQI parameter is there for reflective QS if that is the case. Okay, so these are different protocols, right? Like in end to end. So I talked about radio that there are L1, L2 and L3 protocol. So these are physical MAC and RLC. For handling this QoS flow, there was a new protocol added called SDAP between UE and G Node B. The rest all are similar kind of protocols end to end. Those OSI layer you can consider the 7 layers from 1, 2, 3, 4, 5, 6, 7 same layers, and how in between which network element handles which all layers are indicated here. So I'm not going into detail. I think there will be some session detailing these protocols also. Okay, so now in case I have a network slice, right? So I can have one or more network slice. So what I'm trying to say here is, like, suppose I have slice 1 and slice 2. So within the slice also, either I can have one QoS flow, for example, in this slice, this QoS flow C is indicated, or I can have more than one QoS flow in a slice. Here I am showing two QoS flow A and B. So that means one slice can have one or more than one QoS flow into it. Okay. So now slightly detail on the QoS profile. As I discussed that QoS profile is nothing but the information given to Z node B by SMF, different parameter. What are those parameters? So we discussed that I can have a GBR type flow and I can have a non-GBR type flow. So the one of the parameter is the 5QI. 5QI is nothing but 5G QoS flow ID. Then ARP, allocation and retention priority, we'll talk about. Reflective QoS attribute. GFBR is guaranteed flow bitrate. This is only applicable to guaranteed bitrate type. Then MFBR, which is maximum flow bitrate. This is also applicable only to GBR. Then we have something called notification control, and then we have maximum packet loss rate. And within 5QI, there are many values: resource type, default priority level, PDB, PER, default maximum data burst volume, and default averaging window. I will try to explain each of these quickly in 5-10 minutes. Okay, so these were the parameter I discussed of the profile. Now we'll discuss each of the parameters. So first I'll discuss the 5QI. So as I said, the 5QI will have resource type, GBR, non-GBR, delay critical, priority level. Priority means which of the 5QI will have how much priority. Then packet delay budget, how much delay I can tolerate. And then I have a packet error rate. Then I have averaging window. That means within what time period I have to measure packet error rate, etc. And then maximum data burst volume. And this is for delay critical GBR type. So let's first understand ARP. So this is managed at SDF level. So as you know that you have PDU session, and within the PDU session you have QoS flow, and within the QoS flow you have SDF. So at SDF level this ARP is applied. Meaning what? That the ARP value, suppose if service data flow, a new service data flow is there, and there is a problem of the resources. So which SDF will get the resource? So it is the SDF with higher ARP value. Higher means 1 is the higher compared to 2, 3, or will get the resources. The other case is that a particular SDF may be required to be dropped if its ARP value is less and other SDF ARP value is high, which is requiring the resources, right? So we call it ARP preemption capability and preemption vulnerability in these two cases. If you have any doubt, you can stop me. We talked about reflective QoS attribute. That means It's an optional parameter for non-GBR type QS flow, wherein UV extract the QS flow parameter from the downlink packet and apply into the uplink packet. Then we have something called notification control. What it is that, suppose this is for G node B. If G node B is not able to maintain a QS flow, any question? If G node B is not able to maintain any QS flow, it notifies the network to PCF basically through SMF. So SMF and then PCF, that it is not able to manage the QS flow, right? So in that case, there can be two options. Either it can continue, or maybe that QS flow can be removed from the video session. And in case G node B is again able to maintain that, so it will send the notification to SMF. Basically, SMF is notified whenever a QS flow G node B is not able to maintain because of the resources, and it again notifies once it becomes like it's able to manage the QS flow again. Now there is something called alternate QS profile. Many of the service may have alternate QS profile. For example, YouTube can run in HD, YouTube can run in standard definition, YouTube can also run in the low definition. So suppose the QS flow of YouTube may have alternate QS profile as SD, SD and LD. So what will happen? Suppose Z node B is not able to maintain a QS requirement for HD. So what will happen? It will notify to the SMF and PCF, and it may receive information that, okay, this particular service has an alternate QS profile. Why don't you switch to SD? So the resources as per SD will be applied, and then or low definition as the case may be. And in case resources become available, it can again move back to SD and then to the SD. So this is called alternate QS profile, which is used along with notification control. We discussed about flow bitrate. So bitrate at the level of QS flow is called flow bitrate. So in case of GBR, there will be guaranteed flow bitrate. So what is the minimum bitrate it should have? And then that is not the limit. There can be more than that. So that is defined as a MFBR, maximum flow bitrate. So at the QS flow level, so system will maintain the minimum guaranteed bitrate and will also manage the maximum bitrate which can be provided. So it will kind of limit that with MFBR. Then something called aggregate BR, aggregate umber. So aggregate umber is at session level. So the UV within a PDU session can have a maximum aggregated bitrate of equal to umber defined. So that means the bitrate of QS flow 1, 2, 3 is limited to the session number. Okay, whatever is the subscribed value by the user. Then we have concept of UV level umber. That means if UV is having multiple session, so all the session level umber will be added, and that is called UV umber, aggregated maximum bitrate. And this is also limited to the subscribed value. Now, what are the default value? As we said that at the PDU session establishment, default QS flow is added. So those are the subscribed value of the user, that what default one has to get. So corresponding to that, a particular 5QI will be applied, and it is always a non-GBR type. What is the maximum packet loss rate? So this is the loss rate of a packet which can be tolerated for a particular 5QI. Okay, in a particular 5QI, what is the maximum rate which can be done? And this is always for GBR type QS flow. So now which are the parameter mandatory and which are the parameter are optional. So as you say that 5QI is mandatory, QFI is mandatory, ARP is mandatory, but reflective QAS is optional for non-GBR type. GFBAR is mandatory for GBR type. Notification control is in GBR and it is optional. MPLR is kind of a optional, and rest all are mandatory for some of it, and some of it is not applicable. So this table you can refer anytime. Okay, so let's look at this example, although this is very small written. So this I am trying to say the 5QI values, 5QI values. So what it is? So these are the parameter written in the left, but I'll show you here. So the first parameter is resource type, then priority level and so on. So just see the resource type. So this is the resource type written. These are the 5QI table from standard. So this is the GBR type. So 5QI 1 is GBR, 2 is GBR, 3 is GBR, right? 4 is GBR. So these are GBR type QS flow. I'll take one example. One example is, suppose it is a voice service. So voice service, just see the packet error rate is 10 to the power minus 4, I think. And then the delay is 100 millisecond. And all these parameter will measure within the 200 millisecond. Okay. So these are the parameter for conversational voice. And this is a GBR type because you have to guarantee for a voice call, you have to guarantee. If I just show you non-GBR type, so we discuss about resource type, packet delay budget. Just a moment, I'll take this call. Yes, sir. No, sir, I'll be coming. आपने 3:30 बोला था ना, sir? So I'm still in class. Sir, I'll start. मतलब I'm still in a class, sir. So after class, I'll 45. हाँ, मैं अभी वसुंधरा में हूँ, सर. नहीं, मैं अभी घर से ले रहा था इसको, सर. तो मुझे तो लग जाएगा, सर. तो टाइम लग जाएगा, सर. And so what I can do, I can finish and then straight away start for that, sir. तो 3:30 के बजाय 3 तक पहुंच पाऊंगा या 2:45 हो सकता है, सर. अगर पॉसिबल है तो, सर. ठीक है, सर. Sorry, I have to go for another meeting. I'll try to finish it. So all these parameters are there in this table for GBR type, which I shown you. I'll show you maximum data burst volume. So this is applicable for delay critical GBR, the same table. So here the 5QI values are these. And as you can see, one of the application, let me see if it is V2X, suppose it's a V2X service, V2X type of service. So as you can see that here, the packet loss is 10 to the minus 5, better than the voice, and maximum data burst volume is 255 byte and packet delay budget is 5 millisecond. So that means within 5 millisecond, minimum of 255 byte has to be guaranteed for a delay critical GBR type. And then these are priority. Priority level is 21 for this. And if you recall priority level for voice earlier, so it was priority level was 20 here, right? And priority level for GBR here is the 21. So voice has got more priority even to the V2X kind of a messages. If you look at video service, so this is the video service and compare it with the voice. Priority level is 40. So that means priority will be given to the voice compared to the video. And the delay budget is also stringent in voice. Video it is 150 millisecond. Voice it is 100 millisecond. So what I'm trying to say that there are certain services whose values are stringent compared to other services as per the requirement. And these are provided as part of that. So these are standard value of the 5QI given in the standard. Now finally, last two slides. So what is the difference between QS in 4G and QS in 5G? So in 4G also there was some QS architecture where the concept of radio bearer, then we had S1 bearer, then we had S5 asset bearer, and combinedly these two we used to call ERAB and EPS bearer. The entire bearer is EPS bearer. PDU session is here PDN connection, and here it is one-to-one mapping. So this is one-to-one mapping, where in 5G it was more flexible. I had a single GTPU tunnel handling all the quality of service flow, where it is one-to-one mapping. So if you just compare it, pictorially it will look like this. Left side is the 4G, right side is the 5G. That you have a, so here we call it EPS bearer, here we call it QS flow. Here there is a one-to-one mapping of radio bearer, S1 bearer and asset bearer. Here it is on DRB, I'm having multiple DRBs, and here I'm having a single tunnel. So what I'm trying to say that 5G is more flexible. And then like here I call it 5G QI, that is QS flow identifier, QF5 I call it. There the name given was quality class indicator. IP data flow, here we call it QS flow. In 4G it was EPS bearer. The flow ID is QS flow ID, and here it is EPS bearer ID. Reflective QS is there in 5G, 4G it was not there. Here we call it PDU session, there it was PDN connection. So with this, my session is over. Thank you. And in case you have any question, few question I can take. Any question, or shall we close it?
Excuse me, sir.
Yeah.
It's actually not a question, but after the data packets, three assignments, no question has been floated out, sir.
Okay. So on 5G core architecture, I think the one quiz was shared. And now since we have now covered the 5G core today, so there will be another quiz on 5G core architecture covering part 2 to part 4, which I did. And then on quality of service flow, there will be one quiz coming today.
So in total, how many quizzes will be there, sir?
So we will float the master information document. Sanjay will float that master information document, which will have all the quizzes listed along with link. So I can recall one was evolution, second was key capability, and third was 5G radio. So 5G radio, we had three quizzes, quiz 1, 2, 3. The core architecture, I have two quizzes, and QS flow will have one quiz. We are not having quiz on reflective quality of service, which was taken by IIT Roorkee, and today's session, which was taken by one of the professor, Nagaraju Saab. So those I don't have quizzes, but all the sessions which I took, the quizzes will be out today.
Sir, one more thing for Nagaraj's session, whether the video will be shared, because voice was very low for that session. Some
Okay.
part of that I couldn't understand, sir.
So I think we'll share all the videos, and in case he shares PDF, we'll share PDF also. We cannot insist from other faculty about their PPT, but if he gives, we will share. We'll take his permission and share. Otherwise, video definitely it will be available.
Okay, thank you, sir.
So thank you everyone. If there is no question. So Madhukar, you can continue. I have a meeting in DoT headquarters. I have to move. So please allow me to proceed.
Yes, sir. Yes, sir.
Thank you. Thank you.
Shall we leave, sir? No.
Yes, sir. Yes, sir. I think if you have any query or question, we may stay for a while. Otherwise, we may call it a day, and we shall meet on Monday.
Okay, sir. Thank you.
Thank you so much, sir.
Oh, thank you.
Madhukarji.
Yes, sir. Yes, sir.
Sir,
Go ahead, sir.
Sir, can you, is it possible, can you share all the quizzes what we have attempted so that we can track, or any file mentioning that with roll number these quizzes have been attended, so that if anything we have missed, we can attend very easily that particular thing.
No, you mean to say the answer sheet, or you mean to say the result?
On anything will do, because like the 4 quizzes are there. Like roll number, let's say 101 have attended 1, 2, 3, and didn't attempted 4. Some kind of information, so that anything we have missed, we can attend.
Okay, okay. I will share the list of the participants who has attempted for quiz 1 and quiz 2. And quiz 3, these are
4
open
and
for
5 also.
yes. So quiz 1 and 2 attendance sheet will be shared, and the result will be when it is closed, and the result sheet will be.
Okay, sir. Thank you.
Okay, sir. Thank you.